everyone. I am Aswani, Assistant Professor, Department of CSE AIML at MLR Institute of Technology. Welcome back to another session of Artificial Intelligence. In today's class, we will discuss knowledge representation. Coming 2 or 3 sessions, we will discuss only on the knowledge representation. This knowledge representation is one of the major topic in AI, and it will plays the vital role in AI, artificial intelligence. Let's see what is the overview of this session. So we'll see what is the knowledge representation, how to represent, what are the approaches of knowledge representation. So the knowledge representation KR is crucial in both the cognitive science and AI, artificial intelligence, which involves storing and processing information. If you take cognitive, how the human will process it. If you want to schedule your day, then we will plan accordingly when we will wake up and what we will do next, what are the things we are going to do hourly basis. We will process the information and we will make a note and we will perform the tasks accordingly. In the same way, to solve any problem by the artificial intelligence systems, it needs to process the information specific domain. If the knowledge is represented in such a manner, then it is easy to solve the problems. That is what knowledge representation, which is involving in storing, processing the information. It aims to represent knowledge in a manner that facilitates the inferences. So it can take that knowledge and it will infer the knowledge and it will solve the problems. So what are the programming languages for knowledge representation? There are various programming languages. That is one of the programming, and one of the major one is a prologue logic programming, which represents knowledge using rules and facts. Yesterday in the last class we have seen what is the logic programming and how we can write, and we will see in the next classes also what is the logic programming and what are the basics of logic programming. So it will allowing inference and theorem proving. Next, KL1 is one of the language that is introduced in early 1980s, specifically focused on knowledge representation. The next one is SGML and XML, standard generalized markup language and extensible markup language, and another one is RDF, resource description framework, developed for handling electronic documents in web systems, adding representation of document structures for tasks like information retrieval and data mining system. These will be represent the knowledge in such a manner we can retrieve the information and we can perform the data mining on that using these HTML, XML and RDF. So what are the properties of knowledge representation? If you say this one is a knowledge representation system, then that system should possess these properties. There are 4 properties are there which should possess by the intelligence systems. The first one is learning, efficiency in acquisition, representational adequacy, inferential adequacy. Learning, the system should have acquire, means it should ability to have acquire new knowledge including reasoning, observation and scientific methods. So learning, it ability to acquire new knowledge including reasoning, observation, scientific methods or past experience. It has the ability to learn the things from the past experience or observing the things or proving the scientific methods. That is learning. It should learn the things by observing by the past experience. Next one is efficiency in acquisition, ability to acquire new knowledge automatically without interrupting the human. So without interrupting by the human, the system should have the ability to acquire new knowledge automatically. The third one is representational adequacy. So ability to represent required knowledge efficiently. For example, if you want to perform 2 plus 2 equal to 4, this addition knowledge only it needs to represent. So that is representational adequacy. Represent the efficient knowledge which is required to solve the problem. Only the type of knowledge it is required. Next one is inferential adequacy, ability to manipulate knowledge to infer new knowledge. So already some knowledge is there. From that knowledge we need to infer the new knowledge from the existing one, to manipulate knowledge to infer new knowledge. These are the four properties of knowledge representation system should possess. The next, how to represent representation schemes. There are multiple are there in that: predicate logic, other schemes. Okay, so what is a predicate logic? In this, represent knowledge using rules, facts suitable for expert systems. Already we have seen a predicate logic means it will have the variables and a predicate a relationship with that variables. For example, all humans are mortals. Then we can represent with that as a predicate logic for all x human. Then mortal of x. In such a way we can write that predicate logic. Next, other schemes. In the next 2 or 3 sessions we will discuss the same: semantic networks, frames, conceptual dependency, and other ways of representing the knowledge. Next, what are the applications of knowledge representation, where we will use this knowledge representation? I already said this is the major topic in artificial intelligence. So various applications include expert systems, machine translation systems, computer-aided processing, information retrieval systems, and database front ends. These are the some of the applications. We can write NLP means where we require the knowledge to solve something or to gain some knowledge. So in all the aspects, the knowledge is the basic one. Next, what are the approaches to the knowledge representation? What is the purpose? First, why we required knowledge should be structured. Knowledge is required because knowledge structure are used in AI programs to represent objects, facts, relationships, and procedures, enabling intelligent operation. If you are not represented in structured format, then it is difficult to solve the problems. That's why it required the structured format, so that it is the intelligent system will take that domain knowledge and it will solve the problems. So purpose of knowledge structure is knowledge structures are used in AI programs to represent objects, facts, relationships, and procedures, enabling intelligent operations. Next, types of knowledge structures. Already we will see in the next classes traditional and complex structures, including semantic networks, extended semantic networks, frames, scripts, conceptual dependency structures, etc. Okay. Next, what is a knowledge base? The knowledge base is a special type of database holding domain knowledge. So the knowledge bases are different. For different domains, it will have the knowledge bases. Okay, what its function? Similar to database, storing, updating, retrieving, but more powerful and structured comparing to the databases. Next, how it will be organized: hierarchical structure with the built-in inheritance inferencing capabilities. So one can inherit the properties of from the previous one. In such a manner it will be organized so that it will be simple and you can easily understand that concept. If you are not using this hierarchical structure, it will be huge one. It represent and it will have the more memory and to store also. For each and everything we need to have the same properties multiple times, then duplicate or redundancy will be occurred. That's why organizing the knowledge is also one of the important key. Next, survey of basic knowledge representation schemes. So introduce various knowledge representation schemes without detailing them extensively. So what are the schemes? Then we'll see in the next. So here there are 3 approaches are there. In this session we'll discuss. The first one is the relational knowledge. Next, knowledge representation as a logic and procedural knowledge representation. The first one is related to like a database management system. In that we'll store the data in the form of rows and columns. Here also in the relational knowledge, it is related to the relational database. Let's see. Relational knowledge comprises objects consisting of attributes and associated values. The row of a relational table as done in a relational database. So here how we will represent the data into the relational database. In the same way, here also we'll use the same data tables in the relational knowledge. A table is defined as a set of data values, is organized using a model of horizontal rows and vertical columns. The columns are identified by attribute names, while rows are identified by corresponding values. So serial number, name, like that. Columns and 1, ABC are the values of that attributes. Next, for example, the fact John is a male whose age is 38 years and who is a graduate with a salary of 20,000 may be easily represented in one row in a table with attributes. So we can write a name, age, sex, qualification and salary like this. Under this, the values we can include like John, Mike, Mary, James, their ages and gender, qualification and salary of those. So here we can easily retrieve what is the salary of John, what is the qualification of Mike, what is the age of Mary. We can easily retrieve the values from this structured format. So here this representation helps in storing facts but gives little opportunity for inferencing. Such structures can be used by inference engines. Okay, so we can retrieve the data whatever we have written here in the structured format. But if you ask a question called if PhD graduate PhD qualification person can earn more than this graduate and postgraduate, then there is no answer for this question in this relational knowledge. Why? Because here we will align the data in such a manner so that we can easily retrieve whatever we have stored in this. So we can't gain the new knowledge if PhD person can earn more than this postgraduate and graduate. So here, look at this one. We can easily obtain the answer of the following queries. What is the age of John? By looking this table, we can easily say 38. Next, how much does Mary earn? Then 25,000. Next, so what is the qualification of Mike? There is a qualification column, then we can answer undergraduate. Next, we cannot obtain answer for queries such as does a person having a PhD qualification earn more? Then there is no answer. So inferencing new knowledge is not possible from these type of structures are like a relational knowledge. For this, there is another approach, that is knowledge represented as logic. So we can represent knowledge by using some clause or logic. Inferential capability can be achieved if knowledge is represented in the form of logic. For example, knowledge regarding mortality, such as all humans are mortal, cannot be represented using relational approach. So we can't write this in the tabular format. Instead, it can be easily represented in the logic, predicate logic as follows. For all x, human x, mortal of x. If you say John is a human, then we can say John is a mortal. So we can infer the new knowledge from the existing knowledge, says all humans are mortal. The advantage of the approach are that we can represent a set of rules, derive more facts, truth, and verify them some correctness of new statements. Next, the second one is third one is procedural knowledge. First one is relational knowledge. Second one is knowledge representation as a logic. Third one is procedural knowledge. So this procedural knowledge is encoded in the form of procedures. This one is specific to the domain. For example, if you take a interpreter for a programming language. For example, if you take Java interpreter and C interpreter, the Java interpreter will interpret only Java programming. This interpreter will know the syntax and semantics of the Java. If you specify C program to the Java interpreter, then it won't interpret that one because it is the domain specific and it will only debug Java programs only. It can't debug the C. In the same way, if you give the Java program to the C interpreter, it won't identify the syntax and semantics of the Java. So here, for example, an interpreter for a programming language interprets a program on the basis of the available knowledge regarding syntax and semantics of that language. The advantage of this approach are that a domain-specific knowledge can be easily represented and side effects of action may also be modeled. What are the disadvantages? Also, we can model easily. And here there are the problems, that is completeness and consistency. So completeness means all cases may not be represented. Consistency means that all deductions may not be correct. We can extend the approaches mentioned above for storing knowledge in the knowledge base by organizing data into hierarchical structure that allows the inheritance mechanism. So here we can see the different approaches, and each and every approach the inheritance mechanism, because when we use this inheritance mechanism in the concepts, then it is easy to represent the networks, and we can reduce the size of the network also. So one can inherit the properties of the previous one. No need to repeat the same properties to the subclass. Knowledge organized in the form of semantic network frames are referred to the inheritable knowledge. This will be we'll see in the next sessions, semantic networks and frames. So in this session, we have seen what is the knowledge representation, what is the knowledge base, what are the programming languages for this knowledge representation, and how we can what are the approaches of knowledge representation. We have seen three. One is relational knowledge. Next one is knowledge representation as a logic. And third one is procedural knowledge. In the relational knowledge, we will use the table as a relational database, but here we can't use all there exist type of quantifiers. In the knowledge representation as a logic, we can use the logic, predicate logic. And last one is procedural. So here we can take the example of programming language interpreters. And here the problems are completeness and consistency. Thank you.